All right. Thank you all for joining us after lunch for Billy and Eddie's Declassified Git Survival Guide. My name is Eddie Zaneski. I work at a company called Defense Unicorns. I'm a maintainer for the Kubernetes project, and I'm joined by...
Hi, my name is Billy Lynch. I'm a software engineer over at Chainguard, and I'm also a maintainer for a bunch of open source projects. GitSign, GitTough. I've also worked on a few Git platforms, Google Code, cloud source repositories. So I have a lot of knowledge about Git that Eddie often hits me up for, and that was sort of the inspiration behind this talk.
Yeah. So we're going to start off with some audience participation. I need everyone to take a breath, kind of be honest with each other here. Have you ever borked a Git repo so bad that you had to delete it and reclone?
Yep,
yeah.
yep.
The camera can't see all the hands in the room raised. We all have done this before. It's just kind of the process of learning Git. Even as an experienced software engineer that hasn't spent a ton of time with the Git internals, super common to kind of get yourself into a, you see what I did there?
Hey.
Get yourself into a little sticky situation. And that's, like Billy said, that's kind of the inspiration of this talk. I messaged Billy at around 12 o'clock Mountain Time on a random day. My coworker named Case, who we'll get into this a bit later, was making his first contribution to the Kubernetes project and pretty much just like completely screwed up his PR entirely. And we'll get into the reasons why. But not everyone has a best friend who knows the Git internals and how all of this works. And so that's kind of how we decided to take that experience, put it into a talk form that hopefully we can save some other folks when you get stuck in a sticky situation. So we want everyone to think back to the first time you were using Git. This might be when you were in school, working with a partner on a class project. Maybe you were learning on your own or with a code school. But chances are you're probably working directly off of main, right? We've all been there before we knew what branches were. We knew we had to use this thing called Git to collaborate. And so we are kind of, we take turns back and forth, like committing and pushing up to Git on the same branch. And eventually, we run into a problem. So I have a little repo here. So I've made some changes. I've got my cool little commit here, and my little add message. And I'm going to go ahead and push that up to my remote. And just like you saw on the slide, this scary red and yellow text has probably popped up at least once in your life before. And it's, what does this mean? Why do we hit this?
Yeah, so what happened here? So we're starting with the basics. A lot of you have probably been using Git on a day-to-day. But whenever we're working with Git, Git is what's called a distributed version control system. And so what that means is there's multiple repositories at play. You have your own local copy down here, but then there might be also a remote copy. So this is going to be something that's hosted on GitHub, on GitLab, maybe on your own on-prem hosted server. And so what we need to keep in mind is what is in your state, in your workspace, may not reflect what is in the remote and where is elsewhere, right? So when we make a commit, right, if we make it on our local, even on main, we can make a commit, go from A to B. A exists in both repos. We make a B commit. While we do that, someone else might push C to the remote. And so what ends up happening here is if we try to push, we have these references, these branches on these different repositories. They have different histories. And so if we try to push our B commit to the same main on the remote, that's problematic because remote thinks that C is there and that's the value of the ref, and it doesn't know how to reconcile that because C is not in your history. So this is what it's complaining about here. And so the question is, all right, how do we resolve this and how do we move from here? So Git has the concept of remotes. This may not be something that you're always fully aware of. So a Git remote basically tracks these other copies of the repository. So when you clone a repository, Git will create what's called an origin remote by default. So this is why if you ever do git push origin main, git pull origin main, this is what it's referring to. So this is just an example of a remote that just has a URL that's pointing to the Kubernetes repo. And then this thing here is what's called a ref spec. And all that's doing is it's basically saying, hey, by default, we should track all branches. So branches are tracked under a particular ref. A ref is just a label to a particular commit in the repository. It's our entry point into the repo. So what this is saying, hey, for the refs heads in the remote repo, store them in refs remote's origin. So within our local copy, we actually have multiple refs at play, even if we don't realize that they're actually there. So in our repo, even on a single commit, we might have our main ref, but then there's also this refs remotes. And so for the purpose of this talk, we're going to shorten this a little bit, and we'll just say, when we say main, we're talking about our own local main at refs heads main. And when we say like origin main, we're talking about that remote ref. But in this case, they're pointing to the same place. So in the case here, right, if we start with our repo, we have our commit, we have our B commit. Our main ref might point to that B commit, but origin main is still going to point to A. And so whenever we want to make a change or make, pull in that upstream state into our local repository, we have to go fetch those new updates. And so in this model, right, if we do a git fetch, a git pull, what's going to happen is origin's going to move, origin main will move, but your local main won't, and it'll stay there. And this is a very important distinction to make because, one, your repository doesn't move those refs unless you tell it to. It doesn't automatically sync these ref changes from that upstream. But what's also useful about this is we can manipulate this in a way that we can pull in these changes without actually mucking with our branch directly all the time. So now we're going to talk a little bit more about git fetching and git pulling.
Yeah, and just so it's clear, these arrows indicate the parent of our commit. So that's what we're tracking here. And so, cool, so I'm going to go, OK, so this is telling me I need to git pull before pushing again. So yeah, let's go and do what Billy just showed us. I'm going to git pull origin master, or main. Oh no, I get another scary message. This is hinting at I need to either do a git merge -noff or a git rebase. I've heard git rebase is really scary though. So let's start talking about what happened.
Yeah, so we can fetch in these updates, but it doesn't really resolve that conflict that we saw before. And so that error message is basically saying, hey, we saw that there was a difference. How do you want us to resolve it? So Git itself doesn't actually know what you want. To Git, both of these are technically correct changes. It needs a human to basically make the determination of what do you want to do, right? And so in this example, we have a remote repo. It's already moved on to a B commit. Normally, when we fetch the repo, if we're fetching from the remote to local, what's going to happen is we move the origin. So main will stay the same. This is particular for git fetch. So if you ever wondered the difference between git fetch and git pull, this is what's happening behind the scenes. So when you fetch, it only moves that remote ref. But then when we do a pull, then it's going to try to move our ref with it. So by default, it'll try to do something called a fast forward, which is basically when if there's sort of a linear path in a clean way where there's no conflicts to anything else, we could just go ahead and move the ref. Move ahead, don't need sort of any intervention, and that's good and dandy. So now the question is, all right, well, what happens when there is a situation that we can't resolve?
Yeah. So let's go ahead and let's do this, this first thing here, right, that's telling us. So we're going to do this git merge, no fast forward, which should create us a merge commit, right?
Yes.
Cool. Oh no, I got another scary error message. Cool, so this is telling me I have a conflict in my readme.markdown. So what does a conflict mean in this sense?
Yeah, so like I mentioned before, any sort of conflict is when Git can't automatically determine, we have these multiple changes, how do we actually merge them together in a way? So this is going to happen most commonly like when you modify the same line in a file. There's two different diffs. They both could be right. Maybe you need a combination of them. So it needs a human to go in and basically tell it the difference. So here, we can have our base commit. We can have our two different commits that might have different data in them. So it needs to know, hey, what do you want that final state to be to remove that ambiguity?
Yeah, so let's go ahead and fix that. So I'm going to I'll edit my little file here. And we may have all seen these scary errors. Git is just very scary in general, so I'm going to call everything scary. But we got these scary arrows that we don't really sometimes know what we mean. But now that we know what refs are, we can kind of understand. So this bottom one is telling us that this is actually the ref for our remote origin. And the top one is something called our head, which I think we'll get to later. But for now, let's just pretend that head is our current latest ref that we're working with. So I'm actually just going to take the yo sup here and drop the yo. We're going to clean up that file, make it happy. I'm going to add that readme to tell it we're good to go. And we're going to continue with a git merge -continue. And now it's going to ask me to make a merge commit. And this is what happens on GitHub. You know, when we click that little green button that says merge my commit, it's going to create my merge commit. And boom. So just like that, I have a nice little commit that's a merge commit. And I've actually preserved the history here. So I have Billy's commit from earlier. So.
Yeah, so what happened here, right? So we had two commits. They had different data. What we're doing is we're effectively making this new commit that points to both. So Git commits can actually have multiple parents. You can have any number of parents. I think the most I've seen is like 80, but theoretically it's unbounded. It's just you point to the parent as before. Yeah, and all we're doing is we're saying, hey, we're making this commit. It points to both of those. And by doing that, we actually make a DAG that's valid that we can sort of trace through either path to get to the end. But you have to keep in mind Git, because of the parent relationship, we're going from the end back to the parents, but we can still make that sort of linear association. So we have this in our own ref, and then eventually if we want to push that up to our remotes, we can do that as well and then move that ref. So when we do the push, it's also going to modify the remotes main. But because we have, again, we've resolved this conflict with this merge commit, everything is happy and everything is good.
Yeah, and what we're actually looking at here in terms of the graph, right? So if I tack on a git log one line and a git log graph here, we can actually see the representation of what Billy was just showing. So we can see that this commit right here, where my head, my main is pointed at, has two parents, and that's based on these little arrows here, right? So again, Git commits can have multiple parents, and that's what we're representing here. So the other option on here for fixing this up was a git rebase. Like I said, I think git rebase is supposed to be really scary. How does git rebase work?
Yeah, so rebase is very, very similar. The main difference, though, is it rewrites the history of the commits. So we have the same example from before. We had these conflicting commits. What a rebase does differently than a merge is instead of trying to create this commit that points to both paths, what we're doing instead is we're going to say, hey, before we were pointing B at A, what if we take the same changes that we made in B but apply them to C at first? So this is what it means to rebase. Our base before was A, now we want our base to be C. So all we're going to do is we're going to take the same diff that's being applied from B, apply it to C. We're going to create this new B1 commit. It's going to be a new commit, the same diff, but a different commit because it's pointing to a different parent. And if that's good, and you can still have conflicts here for the same reason, right? If the same line was modified by both commits, we still have to go in and resolve that. But if everything's good, then we can just move things along, and then we get this nice linear history. So a lot of people prefer this for like pull request workflows, stuff like that, just because we can maintain this linear history, because it's kind of how we think about things in pull request. There's no right way to do things. It's somewhat a personal preference. Sometimes you do want to preserve that history with a merge commit. It's going to vary project by project and depending on what you're trying to do. So there's no right way for either of these. And then same before, we can push this up and update the remote.
Yeah. And just to show what this looks like, let me reset this. Right, so now we're going to do a, oh, I lost my history. You get the idea. So if we were to do the rebase properly and I just drop all my stuff, which we could actually fix, we'll get into that later, we'd see that now instead of that one commit having two parents, we have just moved where that parent is supposed to be. And so now it progresses linearly. Cool, so all right, so now let's dig into rebasing a little more. So I've got another repo here, and if we look at the diff between my branch and main, I see, oh, this is a real simple change, right? I've only got a couple different lines here. This should be a real easy rebase for us to do. So I'm going to go ahead and do that. So I'm going to say git rebase. I'm going to put the -i on here for interactive because I want to kind of control what it does. I'm going to tell it to rebase main on top of my branch. And so then I get this other scary little comment message here that's kind of telling me my options. We're just going to leave these at pick for now. I'm going to say, hey, I want to preserve all these commits as is, so I'm going to pick them and use them. So I'm going to save this. And oh, OK, I got another merge conflict. That's because the files have changed. So we can take a look at that like before. We can see I got this README I have to fix and this cats I have to fix. So let me go ahead and do that real quick. So we're going to clean this up. I'm going to add the README. Let me fix the cats file. OK, and then I'm going to tell it to rebase continue. Cool. It's going to have me do a commit here. And then, oh no, it's still broken. I did the rebase, but why is it asking me to rebase again, it looks like?
Yeah, so this is a super common case, particularly if you're like you're working in a pull request. And this is really frustrating because you'll often just be hit with like merge commit after merge commit after merge. Like you have to resolve all of these every single time. And it's like, okay, well, why bother? Like, why do I need to do this so many different times, especially if that diff was so small? Like, why do I have to keep making the same change over and over again? And the reason for this is because we have to think about how rebases actually work. So we looked at a simple example before. But in a typical dev branch, what we're doing is, there's some divergence from main to our dev branch. And maybe we have multiple commits, right? Maybe we have like our initial implementation, and then maybe there's a few follow-up of like fix typo, fix bug, fix white space, whatever. What rebase is doing, because it's looking at each patch, it's actually applying each of the commits one by one. And so what ends up happening a lot of the time is when you're making the same modifications to the same file, what you're creating a chain of different conflicts that Git then needs you to resolve because, again, it doesn't know which one is right. So how this sort of looks is like if we're doing a rebase from our dev branch onto the new main, it's going to look at the hello A, try to apply that. OK, that looks good. All right, let's do B, apply that, do that, looks good, and then do C. But at every single one of these steps, you might have to go through that merge conflict flow. And again, when you're working on like a certain feature on a certain file, it's actually very, very common for this to happen. But we can walk through all this. We apply all the new commits, and then even though they have the same conflict, they are different commits. And at the very end of it, once everything's been applied, then we can move our ref onto the new commit that was created, and then the other ones get sort of discarded. It's actually called orphaned, though we'll go into orphan commits in a little bit. And then we have our clean linear history from there. So how can we avoid this like merge conflict scenario? Depends on what you want to do. So this may not be the best thing always. Sometimes there are commits that you want to make sure that you can preserve. But a lot of the time when we're working with pull requests, we kind of make the mental model of like a pull request is like a single unit of work. And so the question is like, all right, well, if it's a single unit of work, do you actually have to preserve all those commit chains? Maybe, maybe not. Oftentimes, it actually might make more sense for you to what's called squash your commits. And so what commit squashing does is imagine we have this full dev branch chain. What if we just combine them and squish them down to one? Because then that matches our mental model of before. Because what caused that simple diff was we weren't actually diffing each individual commit. All we were doing was diffing the ends of these branches. We were diffing the refs. And so in this approach, what we can do is if we squash, we can make this new commit that just has the same content as the end state, and then we can apply the rebase. And when we do that, now because we only have one commit, even if there's a merge conflict, there's only one merged conflict to deal with. So this is a good thing to keep in your tool belt because yes, we're rewriting history a little bit here, but like within the confines of your own feature and like your own workspace, this is actually very powerful and might simplify a whole slew of different scenarios for you.
Yeah, and so we can fix that up here. So I'm going to abort the rebase that we're doing. And so now let's take a look at the log, see how far back we want to go. I want to rebase my 3 commits here. So I'm going to rebase from head back to 3. And again, head just points at our current working branch where we are. So let's say rebase -i, we'll say head back 3. And we denote the back with the little tilde. And so I'm going to go and I'm going to squash these up. I'm just going to change the pick to an S. And if I get the chance to clean up this commit message, let's drop all the other garbage commits. So now we just have the 1. And so now I can see that I have rebased all that stuff into my one single commit. And so now it's actually much easier for me to rebase main onto my feature branch. And again, normally when you're doing some CI jobs, your Git enforcement, you're going to want to be testing your feature branches against what's on main. So you want to test the resolution of what you're working with plus what's current that you might not have on your branch or what's changed over time. And so that's what I'm going to do so I can go and run my CI job. All right, so I'm going to pick my one commit that we have here. I'm still going to get that merge conflict, but that's OK, because I just have one merge conflict now. So instead of having to run down that rebase chain, I would just have to tidy up all these files and clean up those arrows like we saw before and make one clean commit. And it won't trigger several rebases down the chain. So saves us a bunch. Cool, so we've learned a lot about squashing. But what if I accidentally make a mistake and squash too far or drop an important commit? So let's see what that looks like. So I have my Git history here. I've got a bunch of changes. And I have this super important commit that I definitely should never lose and should not drop. So let's accidentally drop that. So let's rebase. We'll go back, I think, 4. And then I'm going to squash these. And I'm going to realize after I do this that I merged all that garbage into my one commit that I do want to preserve the history and context of, right? I wish I would have kept that as a single commit.
Yeah, so what happens in that last screen is when you select squash, it squashes into the commit above it. So because we had that chain, everything folds into that super important commit. And sometimes you don't want that, right? Because you want to preserve that state as it was.
Yeah, so now I'm realizing I messed up. I merged all those other garbage commits into my commit I needed separate. So what do I do about this?
Yeah, so this is sort of one of the downsides of rebasing because again, you are rewriting the history, you're making those new commits, and you're kind of making those old commits inaccessible because you're moving the ref away from it. Thankfully, there's a nice nifty tool in Git called the reflog. And if you don't know the reflog, if you take anything away from this talk, it's Git reflog is your best friend. So what the reflog does is it creates a log of the ref movements. And so we can use this to basically undo anything that we do in the repository, no matter how severe it is. There is a history limit of what it supports, but if you do something within the same session, it's almost going to always catch it. So here, what we're seeing is if we just type in git reflog, we can see, oh, hey, there was this rebase that was just done. But then back here, we can say, oh, hey, here's when you checked out main. So, and here we have the commit SHA that we can then maybe use to go back and sort of recover the state that was in, even if it may not be directly accessible by a ref or a branch or a tag in your repository.
This is only local.
Only local. It is technically accessible by both local and remote, but again, we're dealing with multiple repos, and the remote repo is not your repo. So the reflog is only local to your local instance, your local repo.
Yeah, so here's my reflog. I think what I want to grab is probably this one, where we first did a move, right? So this is where I'm going to reset my branch to. So if I do let's see. So I'm going to check this out, right? So I can grab that commit SHA, and I'm going to check it out, just to kind of inspect where we are. And I get another less scary but pretty wordy message here. So I normally have my branch name showing my little prompt here, but now I just have the commit SHA. So what does that actually mean? Should I just add a commit to this?
You could, but it's actually not going to be that useful. So this is what Git calls the detached head state. We're not in a horror movie. It's actually very normal. So what does head mean? So again, stepping back, we have to think about how does Git store this data. So Git repos are just a tree, right? You have commits that point to their parents. You have refs that point to the commits. And so whenever we want to traverse the repo, we start from the refs, and then we go backwards through the history to get to whatever commit that we want. So every repository actually publishes their list of refs. You can actually access this for any Git repository. So this was just a ls remote I did on the 6-store gitsign repo. So you can see here's main. There's also pull request refs, which are non-standard refs, but it's something that GitHub does.
They're magic to work with, actually.
They are quite nice. Yeah, and so what is head? So there are different types of refs, so that you might be familiar with branches, so that's going to be refs heads. You might be familiar with tags, which is refs tags. Refs polls is a different type, but again, specific to GitHub. Head is what we call a symbolic ref. And all a symbolic ref is just a ref that points to another ref. And so what this is used for is keeping track of where you are in the repo for your, like, in that given point in time. So like, if you've checked out a commit, like, what commit are you on? If you've checked out a branch, what branch are you on? So all it does is just follow where you are. It's basically like your present working directory for your Git repository. So every ref, everything that gets stored is actually stored in the .git folder. So we can actually go poke and like look at what the value is. So when you check out main, if you look at the file that corresponds to head, you'll see it just says ref says main. So we're on main. So what happens when you check out a commit? So Git will do this happily. It'll go and it'll be like, OK, I know what that commit is. We'll check it out. We'll move head there. All good, all happy, all great. So what happens when you make a commit on this? Git will allow you, like, there's nothing stopping you from doing it, right? Because a Git commit just needs to point to another commit as its parent. However, sort of similar to what we saw with the rebases before, if you move back to main, if our refs are the starting point, how do we get back to C? And this is what Git's complaining about, right? Because since there's no ref, there's no reference to actually to know what's there, there's a risk that you might lose this commit because the only way to get back to it is if you know the particular SHA that corresponds to that commit. And so this is what we called an orphan commit. I mentioned it before, but all they are just commits that can't be reached by any ref in the repository. You can, again, check them out if you know the SHA. So if it's in the ref log, that's how we're able to like undo those behaviors with the ref log. But if your repository gets too big, every so often Git will want to run a garbage collector on your repository. And what it's looking for is basically all these orphaned objects that you might not care about anymore. And so any orphaned commit, Git is going to try to look for and remove from the repository history because it's assuming if there's no ref to it, it's not useful. So to resolve this, all we really want to do, and this is what the error message is telling you, is say, hey, add a ref to that. Like, put something that we can actually make sure we can get back to here later. And so this is going to be, make a branch, make a tag, anything that we can have that sort of relationship in order to go back and, be able to navigate to later.
Yeah. So let's go and fix that. So Billy's telling us that if we look at what head is here, this should actually point to the same commit SHA we're on, and it is actually. Cool. So I'm gonna go back to my other branch. So I'm gonna git checkout dash. That's gonna send me back to my last branch. It's gonna warn me that I have some commits that are orphaned, as we've learned. I'm just gonna actually go and do a reset. We're going to do a hard reset to that commit. So I'm going to reset the reference of the branch that I'm on back to where I want. And if we look back to that original commit before I messed it up with the squash. And if we look, we now have my commit history and my super important commit again. So now I get the chance to try again. And thanks to the ref log, we were able to actually find that commit SHA even though it was potentially lost. So now we're going to circle on back to that pull request that I was talking about earlier. The Kubernetes rebase from hell. I want to give a quick shout out to Case. He's a good sport and told me I could use this pull request as an example. He's a great engineer, but a great example of how we all stumble and trip sometimes when dealing with this stuff.
We have all done this. I've done this. Yeah.
Yeah. So this was an awesome feature. If you have kube control, Case actually added a -- all pods option. So now you can get all of the logs for all pods for a given deployment, which is really sweet. So thank Case for that. But I was helping and mentoring and coaching him how to make this change. Again, this was his first contribution to Kubernetes. And then I get an email notification that his PR was closed. And I say, oh, that's strange. I'm the approver and the reviewer, and I didn't merge it. So why was it closed? So I start scrolling down. I see that the robot added all of these other special interest groups to the PR, which that shouldn't happen. Also, there's like a whole bunch of hidden items there. The bot also tells me now it needs an approval from every single part of the project. He's just making a small change to kube control. This shouldn't happen. Oh God, that is a huge, that's a huge diff there. He's just making a small change, not rewriting Kubernetes. So I understand why he closed his PR. so Case was able to close the PR, kind of tackle it again, get it merged in, all before Billy was able to hop on a call with me. And so again, circling back, like the idea for this talk was like, how could we have fixed that, right? So all the stuff we've built up, all the stuff we've put together, we think we know what happened and the mistakes that were made, and we actually think we know how to fix them. So
yeah, so this was a little bit of sleuthing that we did after the fact. So this is our best understanding based on the current state of the PR. So what we think happened was we started off on a normal commit from main as normal. We made a branch, made a bunch of commits, and then at some point we merged main into our dev branch. If you actually notice in this PR, a lot of this work was done over several weeks, and Kubernetes, the main Kubernetes repo, merges a ton of commits all the time. And so what ends up happening is when we merge that commit, we're merging all of those changes now into our dev branch, but main keeps moving on, right? Main is going to keep having changes, but now we have sort of unrelated changes as we continue down our branch that now look slightly different than now what's at main. So what we're effectively seeing is even though you look at the PR and there's only 35 commits, the actual content that's in it is differing because, again, what we're really diffing is the heads, right? We're diffing the refs. And so what is in our dev branch, because we merged in that main and that main also pulled in all these different file changes, isn't reflecting what's currently at head upstream. And I don't know if you have the SVG. So we pulled the Git history for this. And so this is the SVG graph of the commits.
Yeah, so it looks pretty nice and normal.
Yeah,
Case is working.
Nice linear commits, nice. Yep. Oh God. Here we go. Yep. Oh God. Yep. And so what we're seeing here is the rest of the Kubernetes history tree just being sort of subsumed into this diff that we're seeing. So now the question is, all right, what could we have done about this?
Yeah. Let's see, what could we have done? So if we take a look back here, let's see.
Well, do you want me to run through it first, the explanation? Or?
Yeah, let's do that actually.
Yeah, so what we think we could have done, just in a very simple high-level way, is what's partially causing the problems here is this merge commit, right? So what if we just got rid of it, right? Because all we really want to do is just have our changes. That's what we want it to be reflected in the pull request. So instead of trying to deal with this diff, let's just remove it, simplify things so it's a nice linear thing again. And then before, we saw, where maybe if we try to rebase this, we're going to get, I think there was 35 commits in this PR. That's going to be really annoying to have to resolve those merge conflicts again and again and again. What if we just squash that down, have one commit that corresponds to the PR, and then rebase, move our main to then reflect the upstream main, and then rebase our commit onto main, right? Because that's actually what's matching our mental model for the pull request, and will allow us to sort of make all those changes, pull those in, get up to date with the latest commit, but not have to deal with this big long chain of 35 potential merge conflicts.
So, all right, let's walk through doing that. So if we look at the Git log here, we need to find where you can even see at some point Case tried to revert the merge. And
yes, and key thing for reverts, they don't actually remove commits, they undo the change that was made before.
And so create a new commit.
Right, so it doesn't always, it's just the inverse of the diff, not a remove that commit.
Yeah, so let's see, I'm gonna look for this merge branch, I think we know it's called. So okay, this is where we, went wrong here, right? This merge branch, I think this commit's the bad one.
Yes.
Right, so let's go on and grab that. So we want to get rid of this commit entirely. So let's go and let's rebase to that. And we're going to go interactive, and we also need to do this -R, which stands for no merge or include merge commits.
Rebase merge.
Rebase merge.
I think, if I remember
correctly. So normally Rebase is going to try to help you out and not show those merge commits. We just want to opt into being able to see them. So that's what this -R flag is going to do. I'm going to give it that commit SHA, and then we're going to go back one, so we have it in the...
Yeah, because when you rebase, you want to pick the new base. So since we want to remove that commit, we need to go back one in order to drop that.
To its parent.
Yeah.
Cool, so I got a bunch of text, which is all the extra commits that are in here. I'm just going to ignore and delete all these.
Yeah, so this is all the extra tree that we saw in that SVG before. We don't care about this. We can just nuke it into oblivion.
So let's, up until here. So this is the merge. So we're going to get rid of that. And then we're going to drop his revert merge. We don't want that at all.
Yep.
We're going to drop that. And then, cool, this looks good, right? Or should
Yep.
I squash these?
We can squash them down.
Squash them down. Let's squash these down. So I'm going to say, actually, no, I'll squash them after. So I'm going to fix this up. We're going to clean that up. And then now we can look at the log. And so now we actually see, oh, a nice little shout out to Eddie. I fixed an end-to-end test. Wow.
And also worth keeping in mind here, like even if we mess up this rebase, like we always have the rough log in our back pocket, right? So we can always undo and get back to where we were before.
Yeah. So this is what we want right here, this guy. So this is his original commit that was kind of like the feature, right? So I want to squash all that other extra changes for my and other people's review, and I just want to use this one commit, and so we're going to do that. So we'll rebase -i, and we got to go back one, right? So parent, and then I'm going to pick this one, and all these other ones we're going to squash. So let's do see, these are all his working commits.
So these are like the 35 commits that you would see in the PR. -2 because we removed the merge commit, and we removed the revert to the merge commit.
Cool, so I just swapped all those picks to squash. We're going to get one nice, clean commit here. I'm not going to clean up the commit message, save some time. But now I have a single commit with cases, changes, all squashed. And so now when I do this rebase onto master, I'm still going to get a merge conflict, which is expected because there's all sorts of changes. But thankfully, it's only the files I actually care about if I take a look at the status here, right? These are the files case has actually been working with. And so when I go to clean this up, I just have to tidy up these two files, and I won't get that sort of rebase chain we were talking about because we did the squash before. So.
Yeah. So wrapping up, we'll just say it's still OK to RMRF. Like everyone does it. It's going to happen. I still do it from time to time. But yeah, we hope that this sort of gave you a little bit more knowledge about how Git works, how some of the internals work, and hopefully you can help recover yourself from those weird scenarios if they come up.
Yeah. Thank you all. I think we got about 3 or so minutes for questions, and otherwise we'll hang out and answer some in the back. So thanks for joining us. Yes.
Did you intentionally avoid reuse recorded resolution?
Repeat the question.
Did we intentionally avoid reuse?
Rebase chains you can put in your Git config. There's an option called re-re. It stands for reuse recorded resolution.
So we didn't intentionally avoid them. I don't even know if I know exactly what those do off the top of my head, so I wouldn't expect most people to know what they do either. So that is good to know. One of the things about Git is that it does have like a lot of different options and tools and modes. But yeah, we were trying to keep this like very focused of like just the basics, without knowing.
Quick shout out to a site called botched.
Yes.
That's great. You'll have to tell us afterwards what that does. There's another question. Yes.
I was just going to point out, re is awesome, but if you have things that you added and then removed, you still end up with the conflict.
Yeah.
So like squashing still saves you a lot.
Yeah. Yeah, so to repeat for the recording, even though the re option is great, if you like add and remove files, you still end up having to deal with conflicts, and squashing can help those. Yeah.
When you fix a conflict in a rebase, that does not generate a merge commit, right? Like you're fixing the conflict, but in essence, it is okay.
Yeah. So what it's doing. So the question to repeat is when you rebase, you're not actually creating a merge commit. What it's doing is actually creating a new commit. And so when it's trying to apply that diff, it's basically waiting before that like commit message phase and saying, hey, there's like weird stuff here that needs to get resolved. Please resolve it before we move on with the commit. But it's actually being done as part of like that like pre-commit phase.
But you're manually resolving it, and it's going to take whatever you give it, and that's going to be the new commit.
Yes, exactly.
Yes.
Yeah. So it's taking whatever you give it, and that's what becomes in the new commit.
Yeah, and just like with everything else, we have to stage them by adding them.
Yeah.
And then we move into creating a new commit.
Yeah.
I think that's probably it for questions, but we're happy to hang out and answer some more. But thank you all again for joining us. Hopefully this was
Thank you.
helpful.